Okay, hello students. In these sessions, we will review C string. I'm sure you have already learned about C string in C programming course before, but even you don't remember it, or if you haven't learned about C programming before, don't worry. We will review C string in this class. After reviewing C string, we will study string class in next session, which is newly introduced in C++. So C strings and string class are two different things. So let's first review C string first. C string is an array with base type character, char. So each character of the string stored as an array element. One notable thing is that all C strings end with this \0 character, which we called null character. And this indicates the end of string. So this null character is also known as end of string marker. If you use a literal string such as hello, shown here, such a literal string is stored as a C string in C++ programs. So even you use a hello like this, it is stored as hello plus with this null character. So you might think that the length of this hello string is 5 because 1, 2, 3, 4, 5. But its actual length is 6 because of the null character at the end of the string. So you need to be aware of this when you are using a C string. So how can we declare variables storing C string? So as I just mentioned, that C string is an array of characters. So an array with base type char can store C string. So here we are declaring variable s, which is an array with character type. So this is a C string variable, which can store C string. And because its size is 10, it can store string with 9 characters. The size of C string variable is 10, then why it can only store 9 characters, not 10? Why is that? That's because of the null characters. So as I said in previous slide, all C string end with null characters. So this C string variable can store 9 characters of string and plus 1 null characters. And C string variable is a partially filled array of characters. So here this array stores high man and exclamation mark string. This is a C string. So this S stores high man, which is a C string, and the array elements are filled as shown here, starting from index 0, not 1, starting from index 0 to 7. Here the null character indicates the end of the string, so it is stored at the last element of this string. As you can see here, array is partially filled. So this part of array is not filled. So that's why C string variable is typically partially filled array with fixed large size of array. You have to be careful about overflow. Here, if you try to store string length greater than 9 using this S array variable, overflow occurs because this array can hold 9 characters only. Such overflow will not cause any compiler errors, so it is difficult to notice by the programmers, so attention is needed. So let me show you the demo code for this one. Before showing this demo code, let me explain one more concepts, and then I will come back to this demo code. So here shows two different ways to initialize C string variable when it is being declared. So as you can see here, you can explicitly specify the size of the array. And as we just saw that C string variable need not fill the entire array, the array can be partially filled. And this way of initialization, we omit the array size. In this case, C++ will automatically make the size of the C string variable one more than the length of the string in order to store the null character. So here the size of this short string variable will be 4. So these two initialization and declarations are equivalent. Here the C++ set the size of the array as 4, not 3, even though the string is a length of 3 because of the null character at the end of this string. But you must be note that these two are not equivalent. Even though these two are equivalent, these two are not equivalent. The first one puts the null character at the end of the string because this is a C string. But the second one, this one, does not put the null character at the end of this one. So you can think that the first one is a C string variable, and the second one is not because C string ends with null character. But if you initialize this character array with these brackets and this way, C++ do not automatically include null character here. So this is not a C string. So let's go back to this demo. We'll show this demo example. So this is the demo code here. As I explained in the previous slide, if we initialize character array using these brackets and this way, C++ do not automatically add null character here. So for example, char A if you initialize a character array like this, the C++ will automatically add null character here. So A0 will be H, A1 will be I, and A2 will be this, null character. So this one will be this one, and this one will be this. So if you declare it like this, A will be filled like this one. The C++ automatically adds these null characters. But with this way of initialization, C++ will not include null character here, so this is not C string. And if we print this name variable, 1, 2, 3, overflow occurs because the cout print string until it meets the null value. But because if you print name1 here, because there is no null characters, it will print the next memory, the value stored in the next memory of this array. So let's see, let's run this program and see the output. Comments out this one. First, if I compile this program, and if I run this one, as you can see here, name3 we are printing here, the name3 is DAHYUN, but here DAHYUN, even though it prints DAHYUN, cout do not stop printing the string, but it also prints the next string value, which is SANA. And then it also prints the next string value, which is TZUYU. It keeps on printing it. It's not just printing this name3. It prints here. It prints name3, name2, name1 as well. That's because there is a no null character, so it prints the next string, and then it prints the next string. So it prints until it meets the null characters. Let me show you this in a little bit more detail. You don't need to know about this, but okay, so it's fun to know. So this is the assembly code for this C program. You don't need to understand this assembly code. This is out of scope of this course. I just want to show you the memory layout of these local variables. First of all, here it calls this, it prints the name1 here, and name2 here, and it prints name3 here. You don't need to understand this one, just look for fun.